Okay, so welcome back, or I guess those coming in, welcome. Those continuing to come in, please come in, find a seat. Try not to stand in the back. For those who had stayed from the last session, hi. So today we have a new speaker. His name is Vinayak Mehta, and he will be talking about extracting tabular data from PDFs using Camelot and Excalibur. So please help me in introducing him and welcome him to the stage.
Am I audible? Yeah. Hello, everyone. Is everyone having a good time so far? Like, who all are first-time attendees? Nice. It's my first PyCon too. Let's give it up for PSF and the volunteers, like, for organizing such a wonderful event. Wait. Why isn't this moving? Oh. I think I'll go there. Yeah. So hi, I'm Vinayak Mehta. You can follow me on Twitter here if you like. I work at Grofers as a data engineer in Bangalore, India. If you'd like to know about the things I work on every day, you can catch me afterwards. So I'm here to talk about how you can extract tables from PDF files very easily. I believe each one of us has interacted with a PDF file at some point in our lives, maybe through resumes or research papers. In this talk, I'll briefly go through the history of the portable document format. I'll touch upon some problems I faced while extracting tables from it, and then finally show you some code using which you can do this very easily. So let's begin with a fun fact. Why is Python called Python? And yeah, Monty Python. So while he began implementing the language, Guido van Rossum was also reading the published scripts from Monty Python's Flying Circus, which is a BBC comedy series from the 70s. And he thought that he needed something which was short, unique, and slightly mysterious. And thus we have Python. There are numerous Monty Python references riddled throughout the Python ecosystem, and I'll also tell you about some of them today. Cool, let's quickly go through the history of the portable document format. PDF was born out of the Camelot project to create basically a universal way to communicate documents across various machine configurations, operating systems, and communication networks. This is a memo by Jay Warnock, who is the co-founder of Adobe, where he outlines the Camelot project. You can check it out at the link below. It's a PDF. The goal was to make documents viewable on any display and printable on any modern printer. Hence, the portable document format. It was built on top of PostScript, which is a page description language that had already solved this view and print anywhere problem. A PDF packages components required to build a document, and like text, fonts, vector graphics, and raster images. And these components travel with the document wherever it goes. And a PDF contains instructions to place these components at specific in precise XY coordinates relative to the bottom left corner of the page, which is the origin for a page. So they are just placed at specific coordinates. So words are simulated by placing some characters closer than others, and sentences are simulated by placing words relatively far apart. How is a table simulated then? By just placing words like they would appear in a spreadsheet. So the PDF, the portable document format really has no internal representation of a table structure, which makes it difficult to extract tables out for analysis. Sadly, a lot of open data is stored in millions or possibly billions of PDFs, which wasn't designed for tabular data in the first place. Unlike a CSV, which is very structured, or a JSON, so you guys must be wondering, why are you so obsessed with PDFs? Here's a short intro. I joined Social Corps in New Delhi as an intern in January 2016. It was my final year of undergrad, and as a student, I'd come across various types of PDFs, which were basically resumes, research papers, software manuals. It makes sense for those types of documents to be in a PDF, right? Because you want them to look similar on a variety of machine configurations. So initially at Social Corps, I worked on scraping tabular data from open data sources, which were primarily PDF reports, uh, to extract data, that could be then used by analysts to, uh, uh, for their analysis, basically. So these are some types of PDF tables that I worked with. Each organization that wants to release open data as PDFs comes up with a bizarre and colorful table structure. There isn't any set standard for this. So what is the first thing you do when you want to solve a new problem? You look for existing open source projects that might have already solved it. So similarly, there are already existing PDF table extraction tools. Some of them are open source, some are closed source, like Tabular, which is open source, and PDF tables, which is closed source. So let's go through the problems with existing tools. This is a table. This is a page from a weekly disease outbreaks report released by the Ministry of Family Welfare and Health in the government of India. And it basically contains weekly data about the number of cases and the number of deaths that were recorded in various Indian districts, along with a comment on what action was taken to for those outbreaks. Looks like a very easy table to extract, right? It only has 7 rows and 10 columns. But when you pass it through Tabular, which is an open source tool, you just get this. So you can see that the header is broken into multiple rows, and the comments column is shifted into separate columns. Tabular has a very nice interface, but it either works or it fails miserably. There's no in between. This is the output of PDF tables, which is a closed source tool. It works slightly better, but costs money. And you're either there or you're nowhere, which is the worst place to be. It also either works or it fails miserably. There's no possibility to get even 80 or 90% of a table out, which is not helpful since most of the things in the real world, including PDF table extraction, are fuzzy. So a solution that I tried was PDF to text, which just extracts a text from your PDF file into a text file while preserving the layout using white spaces. But there's a problem with that too, because the output that you get is a text file, and there's a post-extraction step required to make sense of the underlying text data and convert it into a table. You have to write custom code for each different type of table structure, which can become expensive and time-consuming, and that is not scalable. So a solution that we came at Social Corps was Camelot to overcome the problems that of not having a generic PDF table extraction tool, which had knobs included with it. So let's take the example of the same table and let's go through a short demo. Let me just launch a Jupyter notebook. So you can import, by typing it correctly, I can't really see it. You just import Camelot. You do a tables is equal to camelot.read PDF in the name of your PDF. The API is very similar to pandas, like a read CSV or a read HTML. And then you can see that the table, is it visible? Should I enlarge it? Yeah, I can see it now. OK. So the tables is basically a table list object, which just tells you that you got one table on the PDF page. You can access the table using the index of the table, which will tell you the shape of the table. And then you can finally access the table. There's a .df attribute, which will give you a pandas data frame for that table. So like here you can see that it's all extracted very nicely. All the headers are preserved. I can't really see the comments column. Oh, here it is. So all the comments are intact. Yeah, let's get back to a presentation. Oops. Yeah. can't really change it. Oh, it got out of present mode. Yeah, so it's just a screenshot that I put there if the demo didn't work. So why Camelot? Camelot gives you complete control over table extraction with some tweakable parameters. You can override the table areas and columns that were detected by the library itself. And you can tweak the resolution of the image that would be used to do line recognition on a PDF on a PDF page. And there are some other things that are built into the library itself. So each table is a pandas data frame, which can be easily integrated into ETL and data analysis workflows. You get a parsing report for each table, which tells you the accuracy with which the text was assigned to a table cell, and the percentage of empty cells in a table with which you can discard bad tables. And there are some other things like you can flag superscripts and subscripts. So here, the superscript is not really a problem because it occurs after a decimal. But if the decimal wasn't there, then the number 2491 would become 24912. And that would be a problem in your analysis. So you can just use this keyword argument, and you'll get the superscript flagged with those tags. You can strip unnecessary characters, like those dots aren't really required in the text that is inside that PDF. You can just use strip text and pass in the characters that you want to strip, and you'll get a very nice table out of it. Then you can shift text in spanning cells. Then you can also copy text in spanning cells because, yeah, it's just a nice feature to have. And there are multiple output formats. You can export your table to a CSV, a JSON, or an HTML, or an Excel file. There's a command line interface too that you can use. So as you can already guess, the library was named after the Camelot project. A fun fact, Camelot is also the name of the castle in Monty Python and the Holy Grail, which is the movie by the same comedy group. Another fun fact, the Python package index was initially called the cheese shop based on the Monty Python cheese shop sketch. You should check it out. You can install Camelot using a very simple pip install. I've put a comparison with other open source PDF table extraction libraries on that link, so you can check that out too. So Camelot is built on top of PDF Miner, which is a Python library that lets you access the text lines in a PDF along with the coordinates at which those text lines occur. Camelot has two parsing flavors built in. Lattice, you need to choose between one of the two. You can use Lattice if your table is built using lines, and Stream if your table is simulated using white spaces. The names for these flavors were taken from Tabular, inspired from Tabular. But what if you don't want to write code? You can use a web interface that is built on Camelot. And it is called Excalibur. You can just run the web interface using an Excalibur web server and go to localhost :5000. This page will load up when you go to that URL. You can access the PDF that you uploaded earlier underneath the upload button. You can auto-detect tables on a PDF page. This is the same PDF that we were using earlier. Or if the table is really buried inside the text inside a PDF, you can specify the table areas and columns to make your extraction even more accurate. And Excalibur supports all the different tweakable parameters that Camelot comes with. So you can just enter them here and finally view your data and download it in any format that you want. So why Excalibur? Since it's a web interface, it's much easier to use than Python library. You can save your parsing rules, which were your tweakable parameters, and then use them on similar tables in the future. You get to work on your data from the safety of your own home. Your data is safe on your machine. And Excalibur can be configured with MySQL and Celery to make your workloads parallel and distributed. So again, following the same Arthurian theme, Excalibur was named after the legendary sword of King Arthur. Here's another fun fact. The meta-syntactic variables inside the Python literature are called spam and eggs instead of the default foo and bar. You can install Excalibur using a simple pip install. So this is the road ahead with these projects. Right now, you have to choose a parsing flavor. I'm working on having an auto-detection algorithm built in which automatically chooses your parsing flavor. Right now, Camelot only works with text-based PDFs. So there's also a plan to add OCR support so that it can work on scanned images. And there are a couple of minor speed optimizations that can be done here and there. And since you looked at the web interface, it looked very simple since I'm not a front-end engineer. So if any of you know a little bit of front-end, you can help me out there, I think. These are the links where you can find out more about me and about the projects. You can check out open issues on the issues tab on GitHub, and all your PRs would be very welcome. Awesome. So this is a picture of Team Social Cops. I want to thank Rishabh Raj, Deepu Thomas Philip, Ankita Mathur, Shilpa Arora, Varun Banka, and like all of the team who gave their inputs and feedback during multiple iterations of Camelot. And I also want to thank Jacob Singh, Manoj Tiwari, and Deepu Thomas Philip for their feedback on this talk. So yeah, I think we can move to questions.
Yeah, so open the floor up to some questions. So if you do have questions, please come up to one of the mics, and we'll go from there.
Hi.
So I've tried to do some PDF parsing. Some of the libraries I've used is like PDF Miner, PyPDF2, and I've noticed that you can feed it different PDFs from different PDF generators and get different results. And one thing I recently was surprised by was that when you view a PDF in Chrome, it's always perfect. But if you do the Google cache operator on a web PDF, even Google can't convert it into HTML perfectly. So how could that be that the browser displays a PDF perfectly, but we can't convert it to HTML reliably or accurately?
It's possible that the PDF that you're trying to convert is a scanned image instead of like a text-based PDF. So that could be a problem with the PDF. Because like any tool needs to have access to the internal text to convert that into an HTML in the first place. And like if it's an image, you can't really access that text without running some sort of an OCR operation on top of that PDF. Yeah.
Is there some sort of like intermediate format that you can get back from Camelot? I know you have the data frame, which is awesome.
Yeah.
But is there a way to get back some sort of like table object where you could like merge cells and do stuff like that before putting it into a data frame?
What sort of format are you looking for?
I'm just, I have dealt with a number of kind of mangled PDFs where I've had to do like splice cells together and stuff like that.
I think you can easily do that on a pandas data frame. Like if you just need to split cells or like merge them together. I think, right now, you can only access that table as a pandas data frame inside Camelot.
Okay, thank you.
Thank you.
Hi. Kind of adding to what the question he had, how successful is Camelot in extracting a multi-index PDF? Like, what if a couple of rows are clubbed together? Can I extract it to a multi-indexed pandas data frame as well?
What do you mean by a multi-index PDF?
Let's say like a few rows in between here and there are merged together, and I want to preserve the exact same format. but it's actually two separate blocks of text, which is, in Excel you can do it straightforward. You can just merge two blocks of text, but if you are converting an Excel document straight to a PDF, it doesn't look so neat. But if when I try to parse out the data from a PDF, it's not necessarily a straightforward extract.
So if you're talking about those texts being, like if text lines lie in different, maybe different tables, then you'll get them as separate tables. But I think we can talk later, I can, maybe you can help me understand it better. You can take a look at it.
Well, first of all, I can help you with your question, so find me too. Thank you for building this package. Yeah, much needed. So everybody here I know is probably really pleased. Is it possible to extract a list from the PDF, i.e. a table with one cell? Because often that's what we need to get out.
Yeah, it should be possible to extract a table with one column, you mean?
Right, yeah.
Yeah, it should be possible.
Thank you.
I'm curious if you have worked on any examples where there are multiple tables in the same file, if it confuses it, or if you have to reprocess it over and over?
No, so if there are multiple tables on a PDF page, it would extract those as separate tables. I can send you a link for that example. It's on the documentation.
Okay, thank you.
Yeah, I wanted to echo the earlier comment that the tool is awesome. A couple months ago, I had a challenge at work where someone said, we need to find if this thing has a table or not. And so we looked at a bunch of different tools, and we use Camelot heavily. I have a question. If I recall correctly, there was a feature in Camelot that allowed for a sort of visualization of the structure of a table. Okay, I was mixing up the ones, and I thought it was Camelot.
Yeah, that is in Camelot. I didn't include it in the slides because it would have made it longer. But there's an option for visual debugging where you can visualize the text lines that are lying on a table in the table that the library detects.
Yeah, we found that really helpful. I wonder if you could speak a little bit to how that works.
Maybe I can show you the documentation for that. Let me see if I can escape this. So the documentation is on Read the Docs. You can go to the advanced usage. There are multiple examples here which you can use. So there's this whole section on visual debugging where you can basically, let me magnify this. Oops. So you can basically plot all these components that were found by Camelot on a PDF page, which is text, the table boundaries that were detected by Camelot, the lines that were detected, the line intersections that were detected. And text edges is something that is, I can explain it to you later maybe. Which will just show you the text that was on a PDF page. It can help you identify the coordinates for table areas and columns that you need to pass into Camelot. This just generates a matplotlib for each of these different types of components. This is the table that was detected. This is the table boundary that was detected. Similarly, line intersections. So you can play with the different knobs that the library gives you and see if, maybe the intersections were most of the intersections were detected or not, and tweak them to, maybe improve your results. Yeah. Welcome.
Is it able to union one table that spans multiple pages?
No, you will have to write logic to do that yourself.
So each page gets converted to a one data frame, and then you would union all of them?
Yeah, so each table is converted into a data frame, and if a page has two tables, so you'll get two data frames, and then you'll have to stitch all those data frames together using some logic.
Thanks.
Hello. Have you noticed any functionality differences when you have a scanned and OCR PDF with tables in it versus a text-based PDF, that's generated electronically?
What sort of functionality differences? Are you talking about?
Well, a lot of times when you have a scanned PDF where you have to OCR it, the tables come across, differently, at least in that text layer. So I was curious if you've found that with Camelot, if it works pretty good with those scanned and OCR'd.
No, right now it doesn't work with those scan tables. There's a plan to add that as a feature. But
Oh,
right now it
gotcha.
only works with text-based PDFs.
Gotcha.
Yeah.
Okay, thank you. Do you have any interest in generalizing to like text extraction as well as tables?
Like what sort of features are you talking about here?
So like if you're interested in data in the PDF beyond just what's contained in
Okay,
tables?
that way. Yeah, initially I was thinking about it, but right now it's mostly focused on tables. But I can add that as an issue and we can talk about it on GitHub. Yeah.
Did you have one more question? Or?
But it was more of a comment to the last gentleman. I recall when we were trying to sort of solve the problem we had, I can't remember if it was Camelot or Tabular, but one of the libraries had, for some of the things we used like OCR my PDF, and then we passed those things to Camelot. But either Camelot or Tabular had a method for giving you like a probability or like a likelihood that like this thing was correct or not. If that was Camelot, can you speak to that? I can't remember which one it was, but that may speak to the gentleman's question.
Are you talking about the parsing report that I showed? Oh. Yeah, could have been Camelot, I guess. Wait. Are you talking about this parsing report?
Yes, sorry, yes.
Yeah. Cool. Thank you all for coming out today to this talk. Yeah.
So in the next few minutes, I believe there'll be some sprints. I don't believe they're happening in this room, so you can check the schedule. And I'd like to thank Mr. Mehta for coming and giving his talk.